In this part, we'll cover the server side of the push. You might recall the async class from a previous review of server code. Here it is more fleshed out, and we will also send out a push when the build is through. We'll start by reviewing these variables. We have two iOS certificate URLs and passwords for these two URLs. We also have a flag indicating whether this is a production or debug push. When we send a push to iOS, we need a special certificate to authenticate us to Apple. It's not the signing certificate, it's a special cloud certificate. Apple has two separate server deployments. One you use while developing and one during production. They don't mix. Each has its own certificate. An annoying bit is that if you use a phone during development, it will sometimes take up for a day for it to start working for the production deployment. Notice that the production deployment will only work once you install through the App Store and doesn't work with debug builds. The push token is taken from the Codename One account settings in the build server and is used to authenticate with the Codename One server. The GCM server key is the other value from the initial Android registration process. We need it for the Android push. We initialized these fields from a file in the user home directory called REST Builder. The reason for this is both easy maintenance but mostly convenience, so I won't have to include my keys in the source code and constantly remember to remove them. I can just set the values in a properties file and forget about this. I'll take a short detour through the build app method. You might recall where a lot of customization is now happening on the generated application. You will notice we generate the right package name and main class. We also set the right restaurant ID, etc. So the generated app will work as expected. A bit lower we can see the CSS generated by the style objects we configured in the client. This will allow customizing the look of the final restaurant app. Further down, the source target hasn't changed much, but you'll notice the Android target is now implemented. It sets the automated flag to true, which allows sending a blocking build, which returns a result synchronously. This is an enterprise feature, and it's useful for continuous integration or cases such as this, where you want the build servers to do a build for you and return a result. I execute the AND command using the process builder and wait for it to complete. Scrolling a bit down, we can see the loop over the result zip from the synchronous AND build, where we look for the result APK and extract it to send the result to the client. But that's not what I'm looking at. If we have an error, we invoke the method sendPushNotification with the push key if we have it. Going further down, we can see push being sent, and here the arguments are far clearer for the success. The app build completed successfully string is pretty clear, but we also have a semicolon followed by a URL and number 3. If you recall, that means a type 3 push with a string message and a result URL. So it's effectively two separate messages, the first visible, the second hidden. SendPushNotification is actually really simple. Since we do it from the server, we need to post to the Codename One push servers at https push.codename1.com/push/push. with a post method. We need to provide all the arguments in the post body, from token to the device key and certificates. The push server returns a response which we should log for our records in case of failure, but we should normally keep track of in case of a key that expires. In this particular case, this isn't likely since the key is sent with the request, so it should always be 100% valid. There are some additional details, but the basic gist of sending a push message response for this case should be reasonably clear with this code. Thanks for watching. I hope you found this informative.